Hello friends, welcome to second lecture of determinants. Today we discuss on few properties of determinant. First property, if all the rows of a determinant are converted into corresponding columns, then value of the determinant is unchanged. Here what is given? In this property, all the rows of a determinant are converted into corresponding column. Then value of determinant is unchanged. We try to understand this remarks or this property by an illustration. Suppose we have d equals to, for the simplicity I am going to consider only 2 by 2. So 1, 2, 3. What it says, all the rows of a determinant are converted into column. Rows are converted into column. Rows converted into column. Converted into column. Okay. So first row becomes, suppose we say our new determinant. Suppose we say our new determinant as d dash. Then d dash equals to, convert each and every row to column. Okay, so what you get, first row becomes first column, second row becomes second column. Okay, now what is the answer of D? 4 ones are 4, minus 2 threes are 6. So 4 minus 6, what is the answer? Minus 2. Okay, now check the answer of this one. So 4 minus 3 twos are 6. Product of diagonal element minus product of secondary diagonal element. So 4 minus 6, that is equals to again minus 2. Then you can see, if you perform this operation, then value of d dash is nothing but the same value as t. It means value of determinant, you can say value of determinant is unchanged. And this operation is symbolically denoted as Ri to Ci. Ri to Ci. It means convert every row to every column. Convert every row to every column. Okay. So symbolically expressed as Ri to Ci, and value of determinant is unchanged. Okay, see the next thing. For a square matrix E, okay, one more thing. From this, when you convert row to column, for a square matrix A, when you convert row to column, each and every row to each and every column, then value of determinant, you can see in that illustration you got d equals to d dash, and d, that is your matrix A, the value of a square matrix A, and d dash, that is value of a determinant for a square matrix A dash. It means you can say determinant A equals to determinant of E transpose. From this property you can conclude this result also. Okay. Okay, next thing. See the next property. If any two rows of a determinant are interchanged, then the value of the determinant is negative. Any two rows of a determinant are interchanged, then value of the determinant is negative. Again we try to understand this property with an illustration that you have seen in last property also. Suppose we have 1, 2, 3, 4 determinant. 1, 2, 3, 4. What is the answer? There you got 4 minus 6, and you got answer there minus 2. Okay, same way. Now in this property, what is discussed? Any two rows of a determinant are interchanged. Okay, rows are interchanged. It means R2 take place of R1 and R1 take place of R2. It means interchange any two rows. Okay, here only two rows are there. Suppose if you consider large determinant 3 by 3, then you can consider R1 to R2 or R2 to R3, something like that. So here right now in this case we have only two rows, so we can perform which operation? Interchange first row to second row. Interchange first row to second row. Suppose we call that new new determinant as D dash. Then interchange first and second row. So 3 4 1 2. Okay, what is the answer in this case? Answer of D dash. 3 2s are 6, 6 minus 4, that is 2. You can see in previous you got answer minus 2, but when you interchange the rows, when you interchange any two rows, then value becomes opposite. Value becomes opposite. It means you can say D dash equals to minus D. And performing this operation can be symbolically expressed as either, suppose you interchange two rows R1 to R2, then you can symbolically express as R1 to R2. Suppose you interchange second row to third row, then you can express it by R2 to R3. The result is same for column also. It means suppose you interchange any two columns C1 to C2, then in that case also value of new determinant will be negative. In short, when you interchange any two rows in a determinant, value will be negative. Value will be negative. Value will be negative. You can see D dash equals to you, but how much? Minus D. Okay. Now symbolically it can be expressed as here I may be any value, j may be any value. It depends on you which row you want to connect. Symbolically it can be expressed as, sorry, here ri to rj. You can express it this way also, ri to rj, ri to rj, interchange this two. Okay, same thing. Okay, now next property, if any two rows of a determinant are identical, then value of the determinant is 0. Again we try to understand this point by illustration. Any two rows of a determinant are identical. Okay, so we consider a determinant in which two rows are identical. So suppose let us consider we have D as 1 2 1 2. You can see only two rows are there and both rows are identical. Both rows are identical. You can consider any other illustration also, and by that illustration you can check this property. So what is the answer? 2 minus 2 minus 2. 2 minus 2. What is the answer? You got 0. It means any two rows are identical. Two rows are identical, then value of the determinant is 0. Okay. Next property, if each element of a row of a determinant is multiplied by k, then its value get multiplied by k. What is given here? Each element of a row of a determinant is multiplied by k, then its value get multiplied by k. Okay, so suppose we consider our determinant D 1 2 3 4. What was the answer? Now we can orally calculate 4 minus 6. What was the answer? Answer was minus 2. Okay. Now what is given here? Each element. Okay. Wait a minute. Each element of a row of a determinant is multiplied by k. Each element of a row, any row, get multiplied by k. K may be any value. Then its value get multiplied by k. It means value of determinant get multiplied by k. Okay, so suppose we consider that element of first row get multiplied by k, and k suppose we consider here 3. You can select any value, and first row gets multiplied by 3. Then suppose that new determinant will be d dash, then d dash equals to first row get multiplied by 3, so 3 into 1, so you got 3. 3 into 2, so you got 6. Second row remain as it is, 3 4. So what is the answer? You got 3 4s are 12. minus 6 3s are 18. 6 3s are 18. So 12 minus 18, that is minus 6. I'm going to write here now. Minus 6 can be written as, how we can write minus 6? What was the answer of D? Minus 2. What is your key? 3. You can see here. So this can be written as 3 into minus 2. Okay. 3, that is your key. This 3 is nothing but your key. And minus 2, you can see minus 2. Minus 2 is nothing but a value of D. Value of D. It means you got what you get. This is the calculation for D dash. So you got D dash equals to KD. You can see that. Each element of a row of a determinant is multiplied by K. Then its value, it means value of your new determinant, get multiplied by K. Here get multiplied by K. Whatever the value of old determinant, that got multiplied by which one? K. Okay. Next thing. From this property, we can take out any common factor from any one row or column of a determinant. It means from this property, we can say that suppose we multiplied by 3 na, 3 to the 6 it was there, and 3 4 was there. So what is common? You can see from first row you get 3 common. So you can take out that 3. So 3 into 1, 2, 3, 4. Actually this was our old determinant. Okay. And this is our D dash. Okay. So you can say that whenever you get something common from whole row, from any one row or any one column, then you can take it common outside. It means 3 common and you get 1, 2, 3, 4. From first row. Suppose you want to take common 3 from column, then also you can write this way also. So 3 common, then you got 1 1, then here you got 6 4. If you see it properly, then from second column also you get 2 common. So suppose you want to common at the same time 2 also, then here you get 2 3s are 6 and 2 2s are 4. So in this way you can take out common from particular row or particular column. Okay. If corresponding elements of any two rows of a determinant are proportional, then its value is 0. Okay. We try to understand this one here. What it want to say, if corresponding elements of any two rows of a determinant are proportional. So suppose we consider D equals to like this. Suppose we have 1 2 first row. Corresponding elements of any two rows are proportional. Any two rows are proportional. You can see here. Any two rows are proportional. Okay. Any two rows are proportional. It means you can select the second row, element of second row as the multiple of first row. It means suppose you are considering multiple of 3, then here you got 3 1s are 3 and 3 2s are 6, something like that. Suppose you consider multiple of 4, then 4 get multiplied and that you got new row in second row or whatever the row. Okay, so here 3 1s are 3 and 3 2s are 6. Suppose you consider as a multiple of 4. It means proportional. Any two rows are proportional. It means you can symbolically express that. Suppose here we have only 2 rows. So R1 is proportional to R2. Okay. So when you remove these proportional symbols, then you get R1 equals to K R2. K may be any value. So suppose in this case, suppose you consider K as 3, then 3 1s are 3 and 3 2s are 6. So you got R2 like this. Suppose you have more than 2 rows, then suppose R1 and R3 are proportional. Any two rows are proportional. R1 is proportional to R3, then R1 equals to, you can consider K R3. K may be any value. Then in that case you can choose R2 may be randomly, but R1 and R3 are the multiples of some number. Okay, so now in that case, what is the answer you got? Multiple. Then you can see from this previous property, you can take out something common. So you got 3 common. Then what you get? 3 common. Then you get 1, 2. 3 common. So you got 1, 2. Okay. Now see this property. See this property. Any two rows of a determinant are identical. Any two rows are identical, then value of the determinant is 0. Value of the determinant is 0. Then you can see here two rows are identical. It means you got 3 into 0. So what is the answer? You got 0. It means here what it want to say, if any two rows, elements of any two rows of a determinant are proportional like this, then value of the determinant is also 0. Okay, see the next thing, next property. If sum or all elements of a row or a column of a determinant are expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. Okay, firstly I will express it. You will not directly understood this property, but I can explain it to you with a particular illustration. Okay, you can see elements are expressed as a sum in first row, while second and third row as it is. Then you can express that determinant as a sum of two determinant. You can see your first element in first row and second elements are in the second determinant. You can see, while second and third row remain fixed in first determinant as well as second determinant. It means any determinant can be expressed as the sum of two terms with respect to any row. Then you can express it determinant as a sum of two determinants. Suppose you want, let us try to understand this property with an illustration. Suppose we have d equals to, suppose we have 1 4 2 3. Firstly calculate what is the answer of this one. So 3 1s are 3, 3 minus 4 2s are 8, so 3 minus 8, that will be minus 5. Okay, now suppose new determinant you consider d dash. With the help of this one, suppose we express first row as a sum of two terms, then suppose you consider 1 can be expressed as 0 plus 1, 4 can be expressed as, suppose you consider 2 plus 2, 2 3, second row here as it is. Then using your this property, this can be expressed, you can see sum is there in first row in each element, so you can express it as a sum of two determinant by keeping your second row fixed and first element in first determinant, that is 0 2 2 3, plus now your second determinant, that is 1 2, then 2 3. So what is the answer you got? 0 minus 4. 0 minus 4. So it will be minus 4. Then plus 3 minus 4. 3 minus 4. So that will be minus 1. So what is the answer you got? Minus 4 minus 1. So that will be minus 5. And minus 5 is nothing but the answer of D. It means D dash equals to D. It means you can say, when you express it as a sum of two determinant like this, then also the value of determinant remains unchanged. In short, any determinant can be expressed as a sum of two determinant like this, or any determinant can be expressed as sum of these two determinant with respect to any row. Okay. See the next property. Okay, if each element of any row or column of a determinant, right now we discuss on row only, not discuss on column. So if each element of any row of a determinant, the equimultiple of corresponding element of other row are added, then value of the determinant remains the same. So this process can be symbolically expressed as like this: Ri to Ri plus Krj. It means each element of any row. Suppose you consider that row as ith row. The equimultiples of corresponding element of other row. Suppose you consider other row as Rj. Equimultiples of corresponding elements. Equimultiples. So suppose you consider that multiple as k. Then what is given here? Equimultiples of corresponding elements of other row are added. Other row are equimultiples of other row are added. In which row? Ith row. Then the value of determinant remains same. So suppose we try to understood this property by an illustration. Then suppose we have determinant like this D. We consider 2 by 2 only so that we can move quickly also. Suppose we have like this. So what is the answer of this one? 4 minus 6. So what is the answer? Minus 2. Now when you perform operation like this on D, suppose you perform, here we have only 2 rows. So suppose you want to add in which row? Suppose you want to add here in ith row. Suppose you want to add in first row. Then on R1. R1 plus KR2. Only 2 rows are there. KR2. Suppose you consider K as 5. Like this. It means this can be read as in R1 or on R1 performing operation R1 plus 5R2. You can also say that R1 to R1 plus 5R2, or you can say inverse on R1 performing which operation? R1 plus 5R2. Here whatever the first row or whatever the column here first mentioned, that row only change. That row or that column only change. Other rows remain fixed. It means your second row remain fixed here. Okay, so I am going to fix that second row. 3 and 4. Then what is given here? In R1, that thing got added in R1. So what are the elements of R1? 1, 2. 1 and 2. Okay, added. So plus. Added by which operation? 5R2. It means each element of R2 gets multiplied by 5. So this is your R2 right now. So each element gets multiplied by k, that is your 5. So you get 5 3s are 15. Then 5 into 4, 5 4s are 20. So these are the elements you got by performing this operation. So whatever the elements you got 15, 20, that got added to which row? R1. It means in R1 you have to add. This is your R. So 15 got added to first element. 20 got added to second element. So we get here 15 plus 1, that is 60. 20 plus 2, that will be 22. Then 3 4. So 16 4s are 64 minus 22 3s are 66. So 64 minus 66. So what is the answer? You got minus 2. This is the answer of D only. You can see. It means when you perform operation like this on D, then whatever the determinant occurs, the value of that determinant is same as the old determinant. Okay. Whatever we discuss here for row, that thing same remain for true for column also. It means you can perform this type of operation on column also. Okay. So in short, when you perform operation like this on any row, then value of determinant remains unchanged. Okay. Hope you understood it properly. I am going to repeat it again. Here you consider on R1 you want to perform the operation. So on R1 you can say performing R1 plus this row gets multiplied by k, that is your 5. R1 plus 5. Okay. Hope you understood. Okay, now see the next remarks. If delta 1 is the determinant obtained by applying R1 to KRI, delta 1 is the determinant obtained by applying R1 to KRI or CI to KCI, then determinant to the determinant delta, then delta 1 equals to K delta. It means suppose we have D equals to 1, 2, 3, 4. Suppose we have D equals to 1, 2, 3, 4 or delta. Suppose you consider this as delta. Then delta 1, what is given? Delta 1 is the determinant obtained by applying Ri to Kri. You have to perform operation like this. Okay. So suppose delta 1 equals to performing Ri to Kri. So you can pick any one row from this. So suppose we consider only R1. Then on R1, performing which operation on R1? You can perform in K as suppose your 5 R1. On performing 5 R1 on which row? First row. On R1 performing 5 R1 operation. Okay, so that is your determinant delta 1. Then what is the new determinant occur? First row gets multiplied by 5. So 5 ones are 5. 5 gets multiplied. So 5 twos are 10. Your second row remains as it is. So that is your 3, 4. So what is the answer? You got 5 fours are 20. 10 threes are 30. So 20 minus 30. So what is the answer? Minus 10. Okay. What was your k? What was your k? K, that is your 5. So this can be expressed as 5 into minus 2. 5 into minus 2. And 5, that is your k. And minus 2, you can see 4 minus 6. This is the answer, 4 minus 6. That was your minus 2. And minus 2 is nothing but delta. So k delta. So you can say that delta 1 equals to k delta. In short, any row gets multiplied by k. Any row gets multiplied by k. Then value of the determinant becomes k times. Value of your new determinant becomes k times your old determinant. Okay. Okay, see the second remark. Here there is a slight animation problem. That's why this happened. Okay, now see the second remarks. If more than one operation like Ri to Ri plus Krj is done in one step, then care should be taken to see that a row what is affected in one operation should not be used in another operation. It means suppose you have more than something. Suppose you have like this large determinant 1, 2, 3, 2, 4, 6, 3, 2, 5. Suppose this is your determinant D. And when you perform operation like this, but more than one operation, it means suppose you say on R1 performing R1 plus 3 R2. Okay. On suppose you say R2 performing R2 plus 5 R2, 5 R3. Okay. It means suppose when you consider more than one operation at the same time, then care should be taken. Why the care should be taken? Here suppose here what is given? Here care should be taken to see that a row that is affected in one operation should not be used in another operation. Here you can see both rows are different. So this type of operation you can consider, but you cannot after performing this operation you cannot perform another operation like this on R1 performing like R1 plus 5 R3. You can perform it at the same time. Either both these operations you can combine, or you cannot perform two operations like this. Okay, so consider different operation, or you can combine both these operations at the same time like this on R1 performing R1 plus, here you consider 3R2 now, so here you should write 3R2 plus 5R3. Same time you can perform these operations. Okay, you cannot separate these two. Okay, when you see the examples, then you will get better idea for this. So right now I'm not going to discuss on this more. Now see the exercise 4.2. Using the property of determinant and without expanding. What is given here? Without expanding. In exercise 1 to 7, prove that. Okay, it means for first to 7 question you have to prove the result without expanding. You cannot directly expand the determinant. You have to use the property whatever we discussed right now. Okay, so see the first question. This is your first question. You have to prove that answer is 0. Okay, firstly, remember the property when you got the value of determinant becomes 0. So you have cases, few cases. Whenever two rows are identical, first case 2 rows or 2 columns, 2 rows or 2 columns are identical, then value of the determinant is 0. Second is whenever each row entry of the elements of each row gets 0 or each column gets 0, then value of the determinant is also 0. Whenever, another case is whenever elements of one row are proportional to elements of other row, then in that case also you get value of determinant 0. Here you prove that answer is 0. So from this cases whatever we discuss, one cases must arise here. Okay, so see the elements firstly properly. Here x a, y b, z c, x plus a, y plus b, z plus c equals to 0. Okay, firstly we have to prove the result, so we will consider this as left hand side. This is your left hand side. Okay, so two rows are identical, two rows or columns are identical. So you can see here x plus a, then y plus b, then z plus c. X plus a, it means suppose you add this here, or suppose you subtract a here. Either you can make two columns are identical here. How? You can see the second column. You can add the second column to first column. Then what are the elements occur? X plus a, second columns added to first column. Then you got x plus a, y plus b, z plus c. That is your new column occur. And see the last column, that is x plus a, y plus b and z plus a. Then in that case your first column and last column will be same and value of the determinant becomes 0. Or another way, see the second column. If you subtract this second column to last column, subtract this second column to last column, it means on C3 you can perform C3 minus C2. It means subtract this column in C3 vertical direction, then column. It means when you move from left to right. Okay, I'm going to discuss when you move from left to right, then column operations are there. Left to right or right to left, then column operations are there. Up to down or down to up, then row operations are there. That you have to remember. Okay, I'm going to mention it here. Okay, up to down or down to up, then you can use row operation. It means are used in operation while performing operation. While when you perform, it means when you to make any two rows or any two columns are identical, when you have to move from right to left or left to right, right to left or left to right, then you can say that you are using column operation. Column operation, it means on C operations are performed. So here you can see to make a similar elements like this, we have to move from left to right or right to left, you can say. Okay, right to left, it means column operations are performed. Okay, and suppose you have another cases in which you have to move from up to down or down to up, then in that case you can say you have to use row operation. Okay, so now as we discussed, either you can add this column to first column. It means in C1, on C1 you can perform C1 plus C2. Then whatever the entries you got, that is similar as C3. Or you can do another thing as on C3 you can perform which operation? From C3 if you subtract these element from this one, then minus C, minus B, minus C. Okay, then XYZ, you got XYZ. That is same as first column. It means you can perform either these operation or you can perform these operation. Okay, so see the next step. So here we perform these operation. On C1, this is your C1. On C1, you are going to add column C2. Then it will become A got added, so X plus A, B got added to Y, so Y plus B, and C got added to Z, so Z plus C. Whatever here firstly you mention, that column only got change, while the other columns got remain fixed. So this is your second column, that is fixed. Third column, that is also fixed. You can see. Okay. Now, as you can see, first column and last column is same. So we can use that property. If any two rows or any two columns are identical in a determinant, then value of determinant is 0. So you get answer 0. Why? Because C1 equals to, instead of C2, here you got C3. Here you got which thing? C3. C1 equals to C3. Okay. So you got answer 0, and that is your right hand side. Okay, next question. See the second example. Again you have to prove the answer 0. Okay, so as we discussed in first question, two rows are identical. Two rows or columns are identical, then value of the determinant is 0. Two rows or columns. Second thing, elements of one row, any one row, are multiple of other row, then also value of determinant is 0. Third thing, in any row or any column, each and every element is 0. 0 in every row, 0 in each element of a row or column. Then value of determinant is 0. How you can see, this one is not given in your book, so we can discuss it. T equals to, suppose we have 1, 2. Suppose we consider multiple of this one, so 2, 4. You can see these are the elements which are the multiple of this one. Multiple of 2 you can see. So you can see you get 2 common. Or another way, okay, 2 common, then what you get? 1, 2, 1, 2. Okay, then you can use this property. Any two rows or columns are identical, then value of determinant is 0. Or another way, suppose you want to perform on R1. If you perform the operation on R1, you suppose perform R1 minus R2. It means from R1 you subtract this one, then 2 into. You know that from here you can stop and you get answer 0. Or another way, suppose you perform on R1. If you perform R1 minus R2, it means you are subtracting second row. You can see you are subtracting second row in R1. So 1 minus 1, 0, 2 minus 2, that is 0, 1. Now what is the answer of this determinant? 0 minus 0, that will be 0. That will be 0. So 2 into 0. So what is the answer? You got 0. In short, whenever any row, each element in any row is 0, then answer will be 0. Or you can consider direct also illustration also like this. 0 minus 0, then 0. Obviously, it means each element of a row or a column is 0, then value of determinant is 0. Okay, now, so here we try to set the third case in this one. So if you see the elements properly, firstly this is the left hand side. Okay, so if you see it properly, then A minus B, then plus B, then minus C, then plus C, then minus C. So if you add everything to first row or everything to first column, you can perform either operation on row or on column. So suppose you want to perform row operation, then if you perform operation in R1, suppose you add second row and third row, it means up to down or down to up, then row operation. It means you can perform if the operation like this, r1 plus r2 plus r3. Then what you get? Minus b plus b get cancelled, minus c plus c get cancelled, plus c minus c cancelled. Whenever everything added to first row. Okay, same way b minus c, so plus c minus c cancel, minus c plus c cancel, minus b plus b cancel. Same way. So you can perform either row operation or by the same way elements are in particular position, so that either you can perform row operation or column operation. This will give you the same results. So suppose you perform like this on c1 plus c2 plus c3, then also you get 0 0 0. So from among these two you can perform any one operation. So here we perform which operation? Row operation. First operation we perform r1 plus r2 plus r3. You can see here second row elements are added into first one, and same way you can see the operation this one on r1 you can perform which operation? R1 plus r2 plus r3. It means r2 and r3 got added to which row? First row. R2 and R3 got added to first row. So A minus B plus B minus C plus C minus C. Same way. B minus C plus C minus C plus B minus C. How you got? Hope you understood. In R1 you are going to add, it means only R1 got changed. R2 and R3 remain as it is. You can see that. Okay. So this one got added. So C minus C. A minus B got added to first row. So B minus C plus C minus C plus A minus C. Same way. This got added to this one. This got added to this one. Row operation is there. So C minus A plus A minus B plus B minus C. Okay. So now you can see minus B plus B cancel, minus C plus C cancel, minus C plus C cancel. Same way here. So here you get 0. B B cancel, A cancel, C C cancel. You can see here. Same way. C C cancel, B B cancel, A cancel. It means everything got cancelled in first and you got each element 0. You can see. So this operation we have performed. Okay. So now you can see you got which one? 0 0 0. B minus C, C minus C, E minus C. You can see it. So now when we expand it with respect to first row, then 0 into anything, 0 into anything, that will be 0. Same way. 0 into anything, that will be 0. 0 into anything, that will be 0. So answer will be which one? C. Okay. Why? What is the reason? When you expand also, then in that case also value 0. Or in short, now you can remember the property. If each element in any row or each element in any one column is 0, then value of determinant is 0. See the next thing, next question. Okay, this is the particular question. Again you have to prove the answer 0. It means again you have to set any two rows are identical. Okay, here 65, here 75, 86. You cannot easily remember. So for this particular question, you have to remember the operation. You have not to expand the determinant. If you expand the determinant, then you can easily get the answer 0. But no need to expand it here because the strictly instruction is there without expanding. Okay, so get the nearest number of this one. This is the larger number. You can see while these are the smaller number. So which operation you can perform so that you get a nearest number of this one? So 7 9s are 63. 7 9s are 63. 7 into 9, that is 63. Then 63 plus 2, that is 65. So 65 minus 65, answer will be 0. It means this column. Okay, here also you can see 8 into 9. 8 into 9, 72. 8 into 9, 72. And 72 plus 3. So it will become 75. Then it will be subtracted in this one. Then it will be 0. Same way, 9 9s are 81. 9 9s are 81. 81 plus this one. So answer will be 81 plus 5. So answer will be 86. And whatever the 86 you got, if you add this here, in 86 minus, subtract it here, then answer will be 0 here. Okay. So this is the left hand side firstly. Or you can start our calculation. In short, you can see to get the nearest number of this one, we multiply this column. We multiply which column? Second column. Second column by which one? 9. And you can see this column is as it is added to this one. Okay, so here finally what is the answer? 63 plus 62, that is 65. Then that 65 whatever you got, that you can subtract it here, then it will be 0. It means everything you are going to finally add into last column. So we can perform which operation on C3? We can say second column, you can see that got multiplied by 9. So you can say on C3 you have to add 9. So on C3 you can say you have to add 9C2. 9C2. Then this one are added as it is. Okay, so plus C1, you can see 9C2 plus C1. But then what will happen? Everything becomes positive then. So instead of plus sign, we are going to consider negative sign. Negative sign here. Then what you get? C3 minus 9C2 minus C1. 9 minus 9. Minus 9C2. So here you get minus 63. Minus C1. So here it will be minus 2. Minus, minus, same way here minus, same way here minus. Okay, it means we are going to perform which operation on C3? You are going to perform which operation? C3 minus 9C2 minus C. It means multiply second column by minus 9. Multiply first column by minus 1. Minus 9 minus 1, then whatever the result you got, that result you have to add into which column? Last column. Okay, so whatever we discussed it here, this operation, that operation, by performing that operation you got, or you can perform single operation also like this. Suppose you don't understood directly this operation, then you can perform single operation. Okay, I'm going to rub this everything. 65 minus 65 answer will be 0. 75 minus 75 answer will be 0. 86 minus 86. By this way you got last column 0. Or another way you can make two columns identical. Okay. So right now, okay. So when you multiply this one by minus 9, and when you add that result to last column, it means you got on C3, you are performing only C3 minus 9C2. C3 remain as it is. In that you have to subtract minus 9C2. So 65 9 sevens are. This column got multiplied by minus 9. So minus 9 into 7, so you got minus 63. So that thing you can see here. 8 into minus 9, you got how much? Minus 72, that you can see here. Same way 9 into minus 9, so that will be minus 81. Whatever the result you got, that got added in which column? Last one. Okay, 65 minus 63, what is the answer? You got 2. 75 minus 72, that is 3. 86 minus 81, that will be 5. So you can see your first column and last column 235 235 are identical. That's why using that property you got answer C. Thanks for watching. If you like this video, then like it, share it, and subscribe my channel KT Math World for more videos. Thank you.